I'm Anil Kumar, and here is solution of question number 5, page 146 on optimization from Calculus by Nelson. The question is, a rectangle has a perimeter of 440 centimeters. What dimensions will maximize the area of the rectangle? So you can start with sketching a rectangle, right? So we say rectangle has dimensions as length and width. What we are given here is that the perimeter, let's say perimeter P, is equals to 2 times length plus width, and perimeter is given to us as 440 centimeters. So that is 2 times length plus width. Now the question is, what dimensions will maximize the area of the rectangle? As you know, you've done many questions like this. You're expecting square as your answer, right? So this could be one of your objective type questions, right? So whenever you have a question with a rectangle, all 4 sides, okay, then the maximum area is for the square when the perimeter is fixed, right? So with this example, we'll actually show it. So from here we can divide by 2, so we get 220 equals to length plus width, and you can say, well, width is equals to 220 minus length. So first step is to write one variable in terms of the other, right? Now since we need to maximize area, we know area is length times width. We can now write this in one variable, which will be length in our case. So we say area as a function of length is length times 220 minus L. Now it's a good idea to actually open the bracket. So it becomes 220L minus L square. So that is the area in terms of length. Now once you have this relation, you can find the critical number. So these are the standard steps, right? So find the critical number. Also remember that you could actually find the boundary conditions. Length could be from, as you can see in this particular expression. What is the domain of length? Length could be 0, right? It can never be, area can never be negative, right? So length could be 220 or L. So we can say from here that the critical number we need to find, and also we know that the length is actually from 0 to 220, right? Otherwise it is going to be negative. So these becomes our boundary conditions, okay? So let's first find the critical number, which is to say that the derivative should be 0, right? So let's first find the derivative, which is 220 minus 2L, and when you equate this to 0, you get 2L equals to 220, or L equals to 220 by 2, which is 110. You can see 110 is 1/4 of this, right? Once you find length L, you can find the width also. Width equals to 220 minus L, which is 220 minus 110, which is also 110, correct? Now, so you get for critical number, length and width should be 110 centimeters each. You should also show that this is indeed the maximum area. So what you can do is you can find area for 0. If you put 0 here, you know it is 0. And area when the length is 220, that also is 0, right? So we are using the expression right there for area, right? Now these are absurd values because you cannot have a rectangle with these areas, but they help you to really solve the question. So any other area will be maximum area, right? At critical number, that's what we are going to say, right? So we say that the maximum area will be when the length is 110, and it will be 110 square, right? 110 square, since width is also 110, so which could be 11 0 square equals to 12100, right? 12100 centimeters square. Is it okay? Now the question is, what dimensions will maximize it? Therefore in your answer you have to write dimensions, which are 110 centimeters by 110 centimeters, correct? Now once again we have proved that the shape which is going to maximize the area of a rectangle for given perimeter will always be a square, right? So remember that. Thank you and all the best.